Hey guys, my name is Trevor Sullivan, and welcome back to my video channel. Thank you so much for joining me for yet another video in our Rust programming tutorial series. Now, I wanted to kind of switch topics a little bit because the last set of videos that I've been working on has really been focused on the fundamentals of the Rust programming language, learning a lot of the things like primitive data types, how to create your own custom data structures, how to define methods on those data structures, the basics about how traits work, the basics about threading, and just some of the functionality that you'll find in the core standard crate that's included out of the box with the Rust programming language itself. Now, one of the tools that we've been using on a regular basis, but haven't really talked about in too much depth yet, is Cargo. Anytime that we run an application, we often just do a cargo run. We make a change to our source code, we save the changes to our files, and then we go down to our terminal and we do a cargo run operation. Now remember that I think it was back in my video that talked about modules in Rust. You don't strictly have to use Cargo to compile and run a Rust application. You can technically get away with just using the Rust compiler, which is rustc, and that allows you to compile your application into a binary, and then the binary file that results from that compilation process is ultimately what you execute on your system, or perhaps package up into a container image and then distribute to a compute cluster such as Kubernetes, Docker Swarm, and that kind of thing. But Cargo itself is a very important tool, and I would say even though you don't have to use Cargo to build a Rust application, I'm going to guess that 99.5 or more percent of applications that are built using Rust probably just use Cargo because it's very simple to use, and most applications are probably going to have some kind of dependencies on external libraries of functionality. So Cargo not only allows us to build and run our application, but also to bring in these third-party packages, which are known as crates. And Rust crates allow us to import functionality that's been written by other developers and simply incorporate that into our application. Now, you don't have to use crates if you don't want to, but if you don't use any external crates, then you're going to be stuck writing all this kind of functionality yourself from scratch, and that's going to take a lot more time than it's worth if your objective is to build an end application that you can sell online or share with others on GitHub or something like that. So Cargo allows us to import these additional crates. We can use that functionality from external crates in our application, but it also allows us to actually share our application with other people. Now, you might think, well, I'll just host my application source code on GitHub and people can download my application from GitHub. And that is a perfectly fine distribution mechanism for your application. However, for anybody who's using Rust and has the Rust toolchain already installed on their system, they can actually install Rust applications even easier by just using Cargo and installing your application from a crate that's stored in the crates.io registry. So we're going to look at some of the fundamentals of Cargo and better understand how Cargo works and how crates work and things like that. And we'll also take a look at some sample crates that are very popular in the Rust ecosystem, things that you are sure to come across as you are building out your Rust applications. So we're not going to do as much coding this time, but we are going to be taking a look at how packages work in the Rust ecosystem. Now, before we jump into the topic, I just wanted to remind you to head out to my channel, youtube.com/Trevor Sullivan. I'm an independent content creator, so any kind of support that you can provide, whether it is subscribing, liking the videos, watching the entire playlist here on the Rust programming tutorial, and just keeping up to date with my channel really helps me to bring you additional videos like this one. So please engage with my channel here and become part of the community. Let's start by talking about some crates that you might come across in the Rust ecosystem. If you're building a command line application, something you can just run at the terminal with a few command line arguments, one of the crates you might come across is called clap here. Essentially what this is it allows you to parse arguments very easily that are passed into your application at the command line. Now you can again do this without necessarily having to use an external crate, but by using this framework here called clap, it simplifies the process of accepting those input arguments and providing help that's built into your application. So somebody can, do my application dash dash help and actually see a list of the subcommands and all the different arguments and parameters that are available on your application. So clap is one of those popular crates that you'll come across if you're just building a CLI tool and need to expose some arguments. Another one you might come across if you want to build a terminal user interface. I'm a big fan of terminal user interface applications. Essentially, they're kind of graphical applications that run in the terminal rather than in a graphical desktop session. And the reason I like terminal user interface applications, or TUIs, is because they are very efficient. They don't use a lot of data across the network to send and receive data to and from the client. And it's just a really nice way to kind of visualize an application without having to build a full desktop user interface. So CrossTerm is a library that you might come across in the Rust ecosystem that helps you to build terminal user interface, or TUI, applications. Another library that actually can depend on CrossTerm or several other backends is called Ratatouille here. So this allows you to build terminal user interface applications as well, but it provides some out-of-the-box components that you can use to build an application. And as you can see right down here, it actually supports several different back-end libraries. Of course, by default, it uses CrossTerm here, but there's a couple others called Termian and TermWiz that are also supported as alternative rendering backends for Ratatouille here. So this is a community-supported crate here. It's really nice, helps you to build terminal user interface applications, and I'm sure it's one that you'll come across if you're building any kind of dev tools or things that you want to share with the dev community. Serde is another crate that you'll come across. We're actually going to cover this at some point because it deals with some very fundamental concepts like serializing and deserializing things like JSON or YAML data. Essentially what Serde is it's a crate that allows you to serialize data, your custom data structures in Rust. You can serialize that to several different types of data formats. It's actually a pluggable model, so it supports a lot of different data formats like JSON, YAML, et cetera, et cetera. XML, I'm sure, is in there as well. But Serde is a very popular crate, and even though it's not built into Rust, I'm kind of hoping that maybe someday Serde might actually get built into Rust so that you don't have to import a third-party dependency just to do data serialization and deserialization, where we take the text representation of an object and actually import it as a Rust live object. Rocket.rs is another crate here that you might come across. It's basically a web framework that allows you to build things like web APIs. So it's a really nice way to just define what your routes are going to be. You can define your HTTP methods like get, post, put, delete, etc. And it just really simplifies the whole process of building out a web application or web API. So you might come across this as well. They've also got a GitHub project page over here, and it's pretty popular with over 20,000 stars. Tokio, if you start doing asynchronous programming, not necessarily multi-threaded programming, but just asynchronous programming, then you're probably going to come across Tokio. And Tokio is actually used in a lot of web frameworks in Rust as well. So you'll often see that Tokio, even if you're not necessarily explicitly adding it as a dependency for your project, then Tokio might actually be something that's considered a transitive dependency, meaning that it's used by one of the dependencies that you've imported into your application. Bevy is a pretty popular game engine out there. It's an open source project here with over 25,000 stars. So this helps you to build games in Rust. So if you're interested in building out Rust games, 2D, 3D games, that kind of thing, then you'll definitely want to check this out. It's also cross-platform, so it runs on Windows, Mac OS, Linux, and all that stuff. So you might want to check out Bevy, look at the documentation, try to spin up a sample project. There's also a graphical interface. I was actually just playing with this, I think, yesterday, just to kind of see how well it works, because a lot of people were raving about it. So Dioxys is basically this open source framework that's allows you to build graphical applications that are cross-platform. One of the interesting things about it is that it supports several different types of target platforms. So you can use Dioxys to publish a web application. You can use it to publish a server-side rendered application as well, which basically generates all the HTML on the back end and then sends the HTML to the client, rather than the client having to generate and render its own HTML. And it also allows you to run native applications. So if you want to build a desktop application that runs on Windows or Mac OS or Linux, then you'll definitely want to check out Dioxys here because it includes a bunch of components that you would typically find on the web, like buttons, user inputs, like text inputs and that kind of thing. Buttons, labels, all that kind of stuff, things that you typically find on the web. And it actually uses a CSS style of syntax. It also uses a React style architecture. So if you're already familiar with React, then the whole state management and user interface building feels very similar to the architecture behind React. So Dioxys is another really cool open source project. Again, pretty popular with well over 13,000 stars. So those are some examples of some crates that you might come across that help you to build applications much more rapidly. And I hope you can imagine just in your mind that if you had to build all that functionality out yourself, you're going to be hard at work building all those frameworks rather than building whatever application it is that you're trying to create. So feel free, don't be ashamed to take dependencies on those frameworks, learn how those frameworks work, even feel free to contribute to those frameworks so that the entire global development community can benefit from those changes. And hopefully these projects won't die over time as open source often does. We can keep them alive as a community and help make them even better. But we're not going to get too deep into any of those specific frameworks. That's a topic for another day. We just want to understand the basics of Cargo. So to start, I actually want to just go over to our sample project right here and take a look at this special file that gets created anytime that you initialize a new project in Rust. I think back in one of my earlier videos, what we did is probably did a cargo init command or probably a cargo new command. These commands are very, very, very similar to each other. If we do cargo new, that'll just create a new project directory. Whereas if we do cargo init, that effectively does the same thing, but it does it in the current directory. So if we've already created our child directory, then it'll just create it in there. And we also have a couple of different ways to create crates. So there's really two core types of crates. One is an application crate that has an entry point, and that's what we've been dealing with so far. And the way that we know that is because our project has a main.rs file here, and it has a main function. Anytime that we do a cargo run inside of our application here, you can see that our application gets built, compiled, and then executed by the operating system. So that's a application crate, but we also have the ability to create what's called a library crate. So if you are creating functionality that you're not necessarily going to incorporate into an application, but that you want other applications to be able to pull in, very similar to these frameworks that we were just looking at, then you would want to do a cargo init with --lib right here, and that'll create a template for a cargo project, a crate that contains a library rather than a main application with a main function as its entry point, right? So those are really the two different types of crates that we are dealing with, the library and the binary or application crates. So if you want to build an application, maybe a CLI tool that does some really fancy stuff in the cloud, maybe doing some kind of declarative deployment, kind of like Terraform or something of that nature, then you'd want to build a binary application. But if you wanted to build some functionality that you want to incorporate into your application or allow other people to incorporate, that's where you would use a library. Now, if you do decide to build a library, you can actually combine these together. I think you can have a single library, but you can actually have multiple binaries as part of the same crate. The cargo book here actually talks about that a little bit, how you can have multiple applications, but only a single library inside of your crate here. But if you decide to build a library and then publish it on the website called crates.io, that is the registry where other developers will be able to pull in your library and use it in their application. So anytime that we want to install a crate for our application that maybe our application depends on, we can just go out to crates.io here and search for some kind of functionality. Like maybe we want to send emails directly to an SMTP server. So we could search for SMTP and we can just kind of browse through the list of what's available here. Maybe we want to build a web API. So we could search for web framework. We could kind of look through here and see what's available. You'll kind of have to poke around a little bit, and sometimes using the search feature on crates.io isn't necessarily the best route to go. There's probably hundreds, if not thousands, of different posts out there online on various communities where people are asking for guidance on what crate should I use to build a web API, or what crate should I use to build a graphical application, or what crate should I use if I want to interact with a MySQL or PostgreSQL database, that kind of thing. So feel free to use the search here, but also just do, a web search and see if you can find recommendations, ideally recent recommendations of crates that you should be using for your application. Now, to do something really, really simple, I oftentimes like to just generate some random data just to show that we're kind of pulling in an external crate and we're calling some function in the crate. And this is actually a really useful library here called UUID. UUID is just short for Universal Unique Identifier, and it's a standard that allows you to generate kind of random strings that look something like this. And these are very useful because they're pretty much guaranteed to be unique, and they can be used to uniquely identify things like records in databases, for example. So these have a lot of use cases for storing data and referencing unique data within your application. So one of the things that I like to do is just import UUID here, and then it has a function as part of this library that allows us to just create a new v4 UUID. There are some other versions that are provided here as well, but generally I think v4 are kind of the standard ones these days. Now, one other thing I wanted to point out about crates, and we're not going to get too deep into this now, is that crates can actually declare a set of what are called features. So when we add a crate into our application, we're going to see that some of these features are enabled by default. We just call these default features. And then some features may not be enabled by default, but are optional features that you can enable when you install that crate into your application. So let's actually take a look at how to do that with this UUID package here. So back in our application right here, we've been kind of working our way through different concepts by building out all of these modules in separate code files over here. So what we're going to do is just comment out all this functionality where we were dealing with the file system. And then we are going to add a dependency to our application. Back in the video that I did about time and the chrono module, we did actually add the chrono module right here, but we really just kind of glossed over all the details about cargo and crates, and we didn't really talk about them in much depth. So that's why we have chrono listed here. But let's say that we wanted to add the UUID package that we just looked at, or crate, I should say. Well, what we can do is just say cargo add, and take a look at the help. There's a whole bunch of options here that allow us to specify things like local file system paths to additional crates that maybe we're developing locally. We can also specify Git repositories as crates as well, so we don't have to import crates from the official crates registry if we don't want to. But generally, I think you're probably going to, because most people kind of standardize on using that as the publish location. But then if we go up a little bit further here, we're going to see this parameter right here, -- features. We can also look at no default features or -- default features. And what we can do is use these different parameters to control which sub-features of a crate we want to install. So watch what happens when we install the UUID package. So we'll do cargo add UUID. And as you can see, we get all these red dashes here. Well, what do these red dashes mean? Well, that means that there is a feature with the name following the dash that is disabled when we installed UUID. So UUID actually exposes a whole ton of features here, and a lot of these features actually aren't included in the installation by default. You might be wondering, well, why don't they just include all the features? Why would I have to select which features I want to use? Well, with Rust applications, the smaller that your binary is in the end, when you actually compile a release quality binary, the better your application is going to be. It's going to take up less storage, it's going to use less memory, and so we really want to optimize our applications by not installing anything that we don't actually need access to. So if the only reason that we're installing the UUID crate into our application is to get access to the v4 UUID generator, then we don't need a V1 generator. We don't need a V3 generator. We don't need a V5, 6, 7, 8 generator. We only need the V4 generator code. And that, again, helps to keep our application lighter weight, smaller, more nimble, and better performing, right? So that's why a lot of these features are not enabled by default. As you can see, though, one of those features is the V4 feature. So what we actually need to do if we want to use that V4 function is to say cargo add UUID -- features, and then just specify V4. If I wanted to specify additional features, I can use a space or a comma to delimit those. So if I wanted to install V5 and V6 as well, I could just specify all of those. And now you can see that V4, V5, and V6 have been added to our crate configuration here, along with some others that presumably those features depend on as well. So we just had standard before, but now we have a whole bunch of features, but we've still omitted a whole bunch of features that we don't actually need access to, and that just helps keep our application lighter weight. If we come back to our cargo.toml file, we haven't really talked about this in much depth, but this gets created when you scaffold your project or build out your project with cargo init. When you do cargo init with either a library or an application, then you're going to get this cargo.toml file that has some metadata about your application or library. So what is my application's name? And right now it's just based on the folder name that it belongs to, but I can just come in here to my cargo.toml file and just change that to, bacon awesome or something like that. You'll want to go out to crates.io and do a search to make sure that whatever name you want for your crate isn't taken already by somebody else. But assuming that that crate name is free, you should be fine to use that name for your crate and then publish it to crates.io. So I'll just use Bacon Awesome for now, actually, because if I try to publish this, hopefully it'll be available. Let's just do a search for Bacon Awesome, and I don't see any. So that name should be available. And then down here under this dependencies section, you can see that UUID is now a declared dependency for my application here. There's also a version that's been pinned. So I've said I specifically need version 1.4.1 of this particular dependency. You can actually use different version specifiers here that are actually covered in the cargo book here. So if we take a look at specifying dependencies right down here, it talks about some of the different versioning conventions that you can use in order to specify what range of versions of a particular library your application is compatible with. But for now, it looks like by default, it just pinned it to a specific version. And then over here, you can see this array of features that have been activated for my specific installation of the UUID package here. Now that I've imported this crate into my cargo.toml file, I can go straight over to my code right here in main.rs, and I can start to utilize the functionality inside of that crate. Now, oftentimes you're going to want to check out the documentation for a crate, and this brings me to another concept with crates.io, which is the documentation. So if we drill into a particular crate right here, and then we go to the documentation, do you see how it links to docs.rs? Well, what's really interesting is that when you create a crate and publish it to the crates.io registry, the docs.rs platform automatically searches for documentation inside of your library or application and generates that documentation in a standardized format. So if I'm viewing the documentation for the UUID crate or the Bevy crate or the Tokyo RS crate or the Rocket.rs crate, I can always view that documentation on docs.rs here, and it's all provided in a very consistent format. So I can see the crate owners, I can see the crate's homepage, the Git repository where it came from, I can see any transitive dependencies that that crate has, I can see the historical versions of that crate, I can see what percentage of that crate is documented or not documented, and so on and so forth. So it's really nice that the Rust team has provided this infrastructure for not only hosting the packages themselves on crates.io, but also the standardized documentation system that takes your documentation from your module and then exposes it in this standardized interface. I really do like that about the Rust ecosystem. So what we can do is take a look at the different types that are provided by this package. If we drill into UUID right here, you can see we've got this new v4 function right here. And the documentation even tells us that we have to enable the v4 feature in order to use this specific function. So let's go ahead and try to use this UUID struct along with the new v4 function in our application. So we'll go out to the UUID crate for starters. Then we'll look for the UUID struct that we just found in the list of structures right over here. And then inside of that UUID, we have a function called new v4. So let's go ahead and just try to call new v4. And let's do a print line. We'll plug in the output here in curly braces. And then there is actually a toString helper function on here as well, thanks to one of the trait implementations. So we can convert the UUID object to a human readable string. And then we'll just substitute that right here. We'll just say generated UUID is X. All right, so we'll come down here and say cargo run. You can see our application is compiled along with all of the dependencies after I get past all of these warnings right here. So it compiled all of these dependencies, and then it finally compiled our application on top of those dependencies, and then it executes our application. So generated UUID is right there, and every single time that I run my application, the UUID is going to look a little bit different. So that's how we can import crates and use them inside of our application. Now, I'm not going to do a demonstration of this right now, but you can also publish your own crates and applications or libraries to crates.io. So there's actually a cargo publish command right here that we can use after we do a cargo login. So you'll just run cargo login. You'll specify a authentication token that you generate on crates.io. So you'll need to go out to crates.io and log in with GitHub right here. And then once you're logged in with GitHub, you can go to your dashboard and generate an API token that you can paste right here into cargo login. And then after you've done a cargo login, you can just do cargo publish. And typically it'll complain if you haven't committed all of your files to Git, but there's actually a parameter that you can use called allow dirty that will basically skip that check so that you don't have to commit all of your changes to Git before you actually publish your crate up there. But we'll talk about publishing crates some other time. So anyways, that's really what I wanted to focus on for now, is just going over the crates ecosystem a little bit, helping you to understand the Cargo CLI. I strongly encourage you to check out the documentation for Cargo over in the Cargo book here. Just do a web search for Cargo book, and you should be able to find all of this very deep dive documentation into exactly how Cargo works. It is going to be a tool that you need to know as a Rust developer. So if you go to an interview for a job and you need to know about Rust ecosystem, there's a very good chance that you'll be quizzed on how Cargo works and maybe even some crates that you yourself have published into the open source ecosystem. So anyway, that's everything that I've got for today's video. I hope that you learned at least one little new thing from this video. Please, again, support this channel by leaving a like, leave a comment down below. Let me know what other topics you're interested in seeing on my channel. We're going to get progressively more complex as things go on, so we're not just going to be doing the fundamentals of Rust. We are going to do some actually more exciting things and actually build out some applications. So stick around and subscribe to the channel, and we'll see you in the next video. Thanks again for watching. Take care.